Okay, today we're going to be continuing our work in Chapter 6. I do have a startup for you to try here from the Section 6.1 material, so if you want to give these problems a try and then check your answers, then that would be great. Okay, on the first one, find the degree measure of the angle of 35 radians. So if we're starting with radians, we want to multiply by 180 over pi. And when we do that and multiply that out, we're going to get 2005.4 degrees. The second one, find the radian measure for 230 degrees for the 230 degree angle. So this one we'll multiply by pi over 180. Reduce this or reduce that fraction and leave it like this. Or if it WebAssign asks for a decimal, you can give it in this form. Find an angle between 0 and 360 that is coterminal with the given angle. So this angle is given to us. So we want to add 360 degrees to that. And when we do that, we end up with 140. So 140 is between 0 and 360. Number 4, find the length S of the arc that subtends a central angle of measure 20 degrees in a circle of radius 15. So we're going to use the S equals R theta formula. Our radius is 15. We need to convert theta to radians. So we'll do 20 times pi over 180 and get pi over 9. So we'll do 15 times, this is my R and my theta. Multiply those two together and reduce my fraction. And so this answer, if it specifies rounding to a particular number of decimal places, then you could give this answer. So this would be the exact answer. This would be an approximation. Okay, number 5, find the area of the sector shown. So here, looking at this, my angle is 61 degrees. So I need to convert 61 to radians. So that would be 61 over 180 times pi. So I do 1/2 radian or radius squared, so 6 squared times my central angle, and I get 19.164. Okay. All right, so starting with section 6.2, we're going to be looking at trigonometry of right triangles. I will say this is a section that people like a lot and they find fairly easy. It doesn't mean don't watch the video. It just means that hopefully it'll be an easy section for you. Okay, so within a right triangle, and remember that only, like what we're learning today only applies to right triangles. So if we have a right triangle, then what we can do is we can set up some ratios here for finding our trig function. So if I want to find sine and I'm working in a right triangle, then everything is relative to the particular angle you're talking about. So sine is going to be opposite over hypotenuse. Okay, cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then we know cosecant is 1 over sine, or the reciprocal of sine. So if I take the reciprocal of this, then I have hypotenuse over opposite. Secant is the reciprocal of cosine. So this would be hypotenuse over adjacent. Cotangent is the reciprocal of tangent. So that would be adjacent over opposite. So these are, it may be a little overwhelming to learn those, but there are some easy ways to remember that we'll get to in just a minute. Some people have trouble identifying which one is the opposite side, the adjacent side, and the hypotenuse. It's always relative to your angle. So if I'm going to work with theta and I go straight across, then this is going to be my opposite side, and this is going to be my adjacent side. Okay, so in relation to theta, this is opposite and this is adjacent. Okay, now I'm going to change this. I'm going to take this away. If it's in relation to beta, which is here, this is opposite and this is adjacent. Okay, so it is relative to the angle that you're talking about. It's not that in every triangle this is the adjacent side and this is the opposite side. It depends on the angle. Just be careful about that. So there are a few acronyms that are helpful in remembering this. So Sakatoa is the Indian chief. This is one that's pretty common. You've got sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So that's a nice little acronym to use. The problem with that I see sometimes is people don't remember how to spell the Indian chief's name. So if you don't remember how to spell it, then you're not going to be able to get your trig ratios correct. Okay, another one that you might find helpful, some old horse caught another horse taking oats away. So we've got sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent. So, and then some of her children are having trouble over algebra, and there are quite a few other inappropriate acronyms that people have come up with for remembering these. I'm definitely not going to be sharing those with you, but if you're interested, you can Google and find different ones. So, so looking at this, we've got these different relationships that we need to memorize because it's going to be very helpful to know these. They are on your formula sheet, but sometimes even if they're on the formula sheet, I recommend that you memorize them because you're going to use it that much. Okay, so if we go and set these up, if I'm using the angle theta, really doesn't matter about the size of the triangle because my trig functions are always the ratio of the sides. So I could have a smaller triangle that had the ratio of 3 over 5 for sine, or I could have a bigger triangle that had 30 over 50, which is also 3 over 5. So it's the angle that's important, that's going to give me the trig function, not the length of these sides. Okay, so here's one. You're asked to find the 6 trigonometric ratios for angle theta in this given triangle here. So we're missing one of our sides. So this goes back to a basic geometric formula that most of you should be familiar with, and that is the Pythagorean theorem. So the Pythagorean theorem says side squared plus side squared equals hypotenuse squared. Remember, your hypotenuse is always going to be the side opposite the right angle. So this is going to be my hypotenuse, and then I have these other two sides here. So I'm going to let this be my A, and this will be the B. So I'm going to have 2 squared plus x squared equals 3 squared. So 4 plus x squared equals 9. So that means x squared is going to be 5. Take the square root. Technically, it's plus or minus, but because we're talking about lengths of sides of triangles, it's only going to be a plus. So this is going to be equal to the square root of 5. So now I'm ready to find my trig ratios. So the first one I'm going to start with is sine of theta. Okay, so sine of theta is going to be opposite over hypotenuse. So in relation to theta, my opposite side is 2. My hypotenuse is 3. So my ratio is 2/3. So sine of theta is 2/3. If I look at cosine, cosine is adjacent over hypotenuse. So in relation to theta, my adjacent side is the square root of 5, and my hypotenuse is 3. Okay, tangent is opposite over adjacent. So my opposite side is 2, and my adjacent side is the square root of 5. I could go ahead and rationalize this, so I could either leave it like this, or I could rationalize it, and I would have 2 on the square root of 5 over 5 as a rationalized expression. So once I have these basic 3, the rest is pretty easy. We know that the reciprocal of sine is cosecant. So I'm just going to take the reciprocal of sine. So that's going to be 3/2. The reciprocal of cosine is secant. So I'm going to take the reciprocal of this, and I'm going to have 3 over the square root of 5. Again, I can give it like that, or if I rationalize it, I'm going to have 3 on the square root of 5 over 5. And then the last one, cotangent. Okay, cotangent is the reciprocal of tangent. So if I take the reciprocal here, I'm going to have the square root of 5 over 2. And so that's going to be my answer there. So these are my 6 trig ratios for the angle theta. Okay, there's a few triangles that we encounter so often that it's almost helpful to kind of study those as being special. So we have these special triangles or special ratios that we get from these. Specifically, we have the 45-45-90 triangle and the 30-60-90 triangles. We start with the 45-45-90 triangle. Basically, if we start with a square and that square has sides of 1, we draw a diagonal. We know that a square has right angles, so each one of our angles would have been 90 degrees. If we divide this with the diagonal, then we know we're splitting that 90-degree angle into two 45-degree angles. So basically what we've done is we've formed this 45-45-90 triangle, and the two sides are 1 and 1. So using the Pythagorean theorem, I'm going to have 1 squared plus 1 squared equals the hypotenuse squared. So that's going to be 1 plus 1 is 2. So C is going to be the square root of 2, and that's where we get this hypotenuse value here. So if I wanted to look at finding the sine of 45, for instance, the sine of 45 is opposite over hypotenuse. So 1 over the square root of 2, and that rationalized is going to be the square root of 2 over 2. Cosine is adjacent over hypotenuse, so same thing again. Tangent is opposite over adjacent, so 1 over 1 is 1. And you may notice that these are the same values that we have for pi over 4. So the pi over 4 radian measure on your unit circle is equivalent to a 45-degree angle. Okay, if we look at the 30-60-90 triangle, which is the other special triangle, I start with an equilateral triangle. So an equilateral triangle, if the sum of the angles of a triangle is 180, then if I have an equilateral triangle, each one's going to be 60 degrees. Okay, we're going to drop a perpendicular bisector here that's going to divide this side in half. So and one thing I failed to mention is that we're actually going to start with sides of length 2. So the sides of each of our triangle, each side of our triangle has a length of 2. So this one has a length of 2. So when I drop a perpendicular bisector, I get 1 and 1 here. Okay, so I have this triangle, and I know that my hypotenuse is 2, and I know that this side is 1. So using the Pythagorean theorem, then I can find this side. So only looking at the red triangle, which is a right triangle, and using a squared plus b squared equals c squared, I've got one side that's 1. I have one side that I don't know yet, and then I have a hypotenuse that's 2. So I get b squared equals 3. So b is going to be the square root of 3 if I take the square root of both sides, and that's where this value here is coming from. So we start with sides of 2, split one of the sides, and then use the Pythagorean theorem to find the length of this side. So now from here we could do if we're looking at our 30-degree angle, we could do the sine of 30 degrees is opposite over hypotenuse, so 1/2. If I wanted to do the cosine, that's going to be the square root of 3 over 2. Tangent is opposite over adjacent. So 1 over the square root of 3, and we rationalize that, and we get square root of 3 over 3. From the same triangle, we could actually do these for 60 degrees. So looking at the 60-degree angle, the sine is going to be opposite over hypotenuse. So it'll be square root of 3 over 2. The cosine of 60 degrees is going to be adjacent over hypotenuse, so 1/2. And then the tangent of 60 degrees is going to be opposite over adjacent, so square root of 3 over 1, or just the square root of 3. So those are the values for sine for the 60-degree angle, and these were the values for the 30-degree angle. Notice the 30-degree angle is equivalent to pi over 6, and the 60-degree angle is equivalent to pi over 3. So here's our 60 degrees. Okay, one thing, your WebAssign is going to count your problems wrong if you're trying to give it as a calculator answer. because with these 30, 60, 90, and 45, 45, 90 problems, it wants an exact answer, and so that means it wants an answer like square root of 3 over 2, not your decimal answer for that. Okay, so here are some of the special values for 0, 30, 45, 60, and 90. I'm not going to go back through that because basically we've already covered most of that. One thing with 0 here, you can get that from your unit circle, and also 90, which is equivalent to pi over 2. Okay, so on the calculator, you don't have cosecant, secant, and cotangent, so you do have to do those with the reciprocal relationships that we've talked about already. And again, you want to be careful about the mode that you're in. The difference between sine of 1 and sine of 1 degree, you can see is going to give you a different answer. Here you would want to be in radians because there's no degree symbol here, but on this one you want to be in the degree mode. And just remember that to get that in the degree mode, you're going to go to mode, which is to the right of the second function, and press that, and then you'll go down to where it says radian or degree and choose the appropriate one. Okay, here's a couple just for you to try. So as long as you're set in degree mode, you should get this for tangent. For cosine of 20 degrees, you can see what you should get. For cotangent, you would need to do 1 over tangent of 14 degrees to get that answer. And then for cosecant, you're going to do 1 over sine to get that answer. Okay, so I want to move on to some applications of trig functions of right triangles. So one thing in your directions, it may say to solve a triangle, and that just means that you need to be sure that you know all 3 sides and all 3 angles. So typically they're going to give you 3 of those, and you have to find the other 3, and it may be some combination of those. So in this triangle here, you're asked to solve this. So what I'm going to do is I'm going to make a list of what I know. So I know the lowercase letters represent the sides, capital letters represent the angles. So side A, we don't know yet. Side B, we don't know. Side C is 12. Angle A is 30 degrees. Angle B, we don't currently know. And angle C is 90 degrees. Okay, because we know the sum of the angles of a triangle is 180, we do 180 minus 30 minus 90, then we're going to get 60 degrees for angle B. So that leaves us with the 2 sides to find here. So if I'm going to find side A using this 30-degree angle, then I'm going to need to use A, and since I know the 12, then I'm going to use A and 12. So I'm going to set up a trig function that is A over 12. So opposite over hypotenuse is going to be the sine function. So we have to use what we know in the triangle when we're setting this up. So here, what I'm going to do is I'm going to actually cross multiply. So that's going to give me 12 times the sine of 30 equals A. This, if you put this in your calculator, is going to give you 1/2, or if you remember that it is one of the values on your unit circle or one of those special triangle values, then you're going to do 12 times 1/2, and that's going to give you 6 for A. Okay, at this point, we could do the Pythagorean theorem, but let's go ahead and practice setting it up as a trig function. So if I'm going to use the 30-degree angle, I'm going to need to find B. So I'm going to use B. I always like to go back to what was given to me at the beginning, just in case I happen to mess up on A. I know 12 is right, so I'm going to do B over 12. So that's adjacent, in relation to my 30-degree angle, that's adjacent over hypotenuse, so that's going to be cosine of 30. So again, I'm going to cross multiply. So I have 12 times the cosine of 30 equals B. So cosine of 30 is the square root of 3 over 2, and this is where they're going to want you to substitute square root of 3 over 2 instead of giving the decimal for that. So 2 goes into 12 6 times. So my answer is going to be 6 on the square root of 3 for my answer. Okay, so applying this to some word problems, a few definitions here. We have what's called the horizontal. So the horizontal may or may not be on the ground. It's usually going to be your line of sight. So if you have a person standing here and they look straight across, then that's your horizontal. If they look up, then that's going to be your angle of elevation. So angle of elevation is going to be looking up. So we have the horizontal, we have our angle of elevation, and then whatever they're looking up to. So this person's up here, they're looking up to that. So that's going to be the line of sight looking up. So we've got the horizontal going straight across and the line of sight going up here. Sometimes they look down though, so maybe the person's not up, maybe they're down on the ground. So you've still got the horizontal going straight across, but if you look down from the horizontal, then that's called an angle of depression. So if you're looking down to get your line of sight, that's angle of depression. If you're looking up to get your line of sight, then that's angle of elevation. Okay, so this is just kind of showing the same thing here. Sometimes if you're actually following some kind of physical object like a hillside, then that can be called an angle of inclination. Okay, so here we have a giant redwood tree casts a shadow that's 532 feet long. Find the height of the tree if the angle of elevation of the sun is 25.7 degrees. Okay, so we're going to draw out what is being described to us here. So we've got our tree, and hopefully you're a better artist than I am, but here's our tree, our giant redwood tree, and it casts a shadow. This is, for some reason, confusing to people, but I want you to think about where, if you were standing outside, where's your shadow going to be? Your shadow is always going to be on the ground, okay? So we've got the sun. Let's say the sun is up here. Okay, and so the rays of the sun are coming across the tree here, and it's going to form a triangle. And the shadow is actually going to be down here on the ground. So this is our shadow. I've seen a lot of people try to tell me that the shadow is up here in the air, but the shadow's on the ground. Okay, so the giant redwood tree casts a shadow 532 feet long. So this is 532 feet long. Find the height of the tree. Okay, so here's our tree. That's what we're trying to find. If the angle of elevation of the sun is 25.7. So here's our horizontal. Angle of elevation tells me we're looking up. So angle of elevation is 25.7 degrees, and I'm trying to find this side here. So that's going to be my X. Okay, so in relation to my 25.7 degrees, I know the opposite side and I know the adjacent side. So if I know the opposite side and the adjacent side, then the trig function that uses opposite and adjacent is tangent. So I'm going to set this up using tangent. So tangent is the opposite, which is x, over the adjacent, which is 532. So now all I have to do is actually just cross multiply. The good news is that on these, because these are not special angles like 45 or 30, 60, 90, you just put these in your calculator, okay? Be sure you're in degree mode because you're not going to get the right answer if you're not. We'll cross multiply. Okay, and so when I put this in my calculator, I'm going to get the right answer for this. So the correct answer is 256.03. This one, it's going to be best to go ahead and round it to the nearest whole number. So 256 for that one. Okay, and here's a nicer drawing of the tree. Okay, so looking at another one, from a point on the ground 500 feet from the base of a building, an observer finds that an angle of elevation to the top of the building is 24 degrees and the angle of elevation to the top of a flagpole atop the building is 27 degrees. Find the height of the building and the height of the flagpole. Okay, so we have our building here. Actually, I'm going to draw. or have a little bit more room. Okay, so here's our building. So from a point on the ground, 500 feet from the base of a building. So here's the base of my building. So 500 feet away. So this is going to be 500 feet. So here's my point, 500 feet from the base of a building. The observer finds that an angle of elevation to the top of the building is 24 degrees. So if the person's standing here and looking at the top of the building, then this is going to represent my angle of elevation. So that's going to be 24 degrees. The angle of elevation to the top of a flagpole atop the building is 27 degrees. So apparently we have a flagpole on top of the building. So when the person stands here and looks up at the flagpole, that angle is 27 degrees. So if I take this and I go and try to find this, I'm going to let this be X, and this is going, and then we'll deal with the other part in just a minute. So if I'm looking at the first triangle that I drew here, the first triangle, I know the opposite and I know the adjacent. So if I'm working with opposite and adjacent, I'm again going to be using tangent. So the tangent of 24 degrees is the opposite side, which is X, and the adjacent side, which is 500. So X is going to be 500 times the tangent of 24 degrees. So I get X is 222.6, and that is in terms of feet. Okay, so that's the height of the building. Now I need to find the height of the building and the length of the flagpole. So I've got to find them each one. So what I'm going to do is I'm going to let Y represent this height here, and 27 is the angle of elevation for this one. So for the 27 degree angle, my opposite side is Y and my adjacent side is 500. So I'm going to set this up very similarly. I'm going to do the tangent of 27 is Y over 500. So if I cross multiply, I'm going to have Y is going to be 500 times the tangent of 27. So Y is going to be 254.8 feet. Okay, so Y represents the building plus the flagpole. If I want to find the height of the flagpole itself, then I'm going to have to take the height of the two together and subtract the height of the building. And that's going to give me a height of 32.2 feet for the height of the flagpole. So this is maybe a little bit clearer drawing here. Okay, I have a series of problems that I would like for you to practice and then check your answers, because it's really important that you can take the wording of this and translate it into a triangle yourself. So really practice that part of this. So pause each one, try the problems, and then check to see how you should have done the problems. Okay, so for this one, from the top of a 200-foot lighthouse. So we have a 200-foot lighthouse. Okay, so it's 200 feet tall. The angle of depression of a ship in the ocean is 23 degrees. So from the top of the lighthouse, so we're already up here, and if we look at the horizontal, which goes across here, then the angle of depression to a ship in the ocean, angle of depression is looking down. So my angle of depression to the ship in the ocean is going to be 23 degrees. Okay, so over here is the ship in the ocean, and so we have to find out how far is the ship from the lighthouse. So we want to find this distance here, the distance from the ship to the lighthouse. Okay, so we know that this is 23 degrees. That's our angle of depression. So a couple things we could do. One is we know this is a right angle, so we could do 90 minus 23 is going to give me 67. That's one way to do it. Another would be to remember that if you have parallel lines cut by a transversal, that your alternate interior angles are going to be equal to each other. So 23 degrees here is going to mean this one is also 23 degrees. So a couple ways to arrive at these angles. And so it doesn't matter really which one you work with, but you can do this problem in a couple ways. So if we've got to find this side, we know this side, and we know our angles. Let's just work with this 23-degree angle here. So we have opposite and we have adjacent. So that means we're going to be using tangent again. So tangent of 23 is opposite over adjacent. So a cross multiply. We'll divide by the tangent of 23 degrees. So 200 divided by the tangent of 23 degrees gives us 471.2, and that would be in terms of feet. So while it does seem like quite a few of our problems have used tangent, it's not a guarantee that they all use tangent, but I will say I think the majority will, just simply because it's more rare that we know the hypotenuse, and so tangent is the one that uses the sides of the angle instead of the hypotenuse. Okay, so try drawing this one out and then and solving it, and then check your answers. Okay, so here we have a 20-foot ladder that leans against a building. So this is our building. We have this ladder that's leaning against the building that's 20 feet. And the angle between the ground, so this is our ground, this is our ladder. The angle between the ground and the ladder is 72 degrees. How high does the ladder reach on the building? So that's going to be this part here. So while my triangle is kind of small, I can still see that I have the hypotenuse given to me. I'm trying to find the opposite side. So if I'm working with hypotenuse and opposite, this is a case where hypotenuse and opposite is going to involve sine. So I'm going to use the sine of 72 equals the opposite side over the hypotenuse side. Cross multiply. And we get 19.0, and that would be in terms of. Okay, on this problem, I'd like for you to try it and then check your work. So this one we have, it says a laser beam is to be directed toward the center of the moon, but the beam strays 0.5 degrees from its intended path. So I'm going to draw the moon over here, and then here we have Earth somewhere over here. So if we are looking at this, we're going to kind of base everything off the center of the moon here. So it says we have a beam and it strays 0.5 degrees from its intended path. So how far has the beam diverged from its assigned target when it reaches the moon? So the moon is 240,000 miles. So 240,000 miles is going to be this distance in here. And so we're basically looking to see how far off it's going to be. Okay, so it's going to have diverted 0.5 degrees from where it originally was scheduled to hit. So if we're only off by half a degree, is that going to matter? Or are we still going to, is the beam still going to hit the moon? So we don't know if it's up here or down here somewhere that it's going to hit. So if I look at this, I need to basically figure out this distance. That's how far it is off from its target. So this is where it would hit, and this is where it should have hit. So that's going to be opposite over adjacent. So I'm going to do the tangent of 0.5 degrees is going to be x over 240,000. So cross multiply. Okay, and I get x is 2,094.4 miles. Okay, so this distance in here is 2,094.4 miles. Okay, here we find out the radius of the moon is about 1,000 miles. So if the radius, which would be from here down, is 1,000, then what happens is if our laser beam is off by 2,094, then it's going to be up here somewhere and it's going to totally miss the moon. So will the beam strike the moon? No, it's not going to strike the moon. Okay, here's another one for you to try. Okay, we have a 500-foot guy wire is attached to the top of a communications tower. So here's our communications tower, and we have a 500-foot guy wire that's attached to the top of it. So a guy wire is like those wires you see on telephone poles that help to hold it and give it support. So this is the guy wire here, and it's going to be 500 feet. If the wire makes an angle of 75 degrees with the ground, so here's our ground and here's the wire, so this is going to be 75 degrees. How tall is the communications tower? So this is the height of the tower. So I'm going to be working with opposite and hypotenuse. So that is going to be my sine function. Sine uses opposite and hypotenuse. So the sine of 75 is going to be opposite over hypotenuse. Cross multiply, so x is going to be 500 times the sine of 75. So that's going to be 482.96, or we probably are going to round that to the nearest foot, so 483 feet for the height of the communications tower. Okay, try this one. Okay, here we have the beach. So I've got the beach here. A man is lying on the beach. So again, forgive my artistic ability. The man's lying on the beach flying a kite. So here's his kite. Okay, so he's flying the kite and he holds the end of the kite string at ground level and estimates the angle of elevation of the kite to be 70 degrees. So angle of elevation is going to be from the horizontal looking up. So that's going to be 70 degrees. If the string is 400 feet long, so here's the string of the kite. How high is the kite above the ground? Okay, so the height of the kite is going to be represented by x. So for this one, I've got, in relation to my 70-degree angle, I've got my opposite and my hypotenuse. So this is another sine. So I'm going to do sine of 70 equals x over 400. Cross multiply, so x is going to be 400 times the sine of 70. So x is 375.87, and since we're rounding to the nearest foot, it's going to be 376 feet. Okay, that takes us to the end of this section. Hopefully you kind of were getting the idea of how this works as far as all of these are going to be a right triangle. You just need to kind of figure out what parts make up the right triangle and which trig function you use as a result of that, and then you should do well on those. So let me know if I can help you, and have a good day.